In this video, we're going to have a look at turning recurring decimals into fractions. Now, a recurring decimal is essentially a decimal that has a repeating pattern of digits. So, for example, it could be 0.3 recurring, which if we wrote it out in full would be 0.33333 continuing in that sort of pattern. Examples of non-recurring decimals could be, for example, 0.42. Okay, that's got a finishing point at the end of it, so it can't be recurring. Another example of when it wouldn't be would be pi. There's no repetition in the digits that occur for the rest of pi if you type it in, so it's not counted as recurring. Other examples of recurring could be 0.025 with the dots over the 2 and the 5. So it's those two digits that repeat. So 0.02525, etc. A third example could be 0.435 with the dots here and here. All the dots mean is everything from the start of this section to the end of the last dot. That is our repeating section. So it's 0.435, 435, etc. Last example, 0.05. Okay, again, it's only the 5 that's repeating this time. One dot, the same as it was at the top. So it's just that 5 that repeats. So moving on to the topic in hand, we might be asked to convert this decimal here into a fraction. And I've put all the steps that we're going to go through at the bottom here so you can follow through as we're doing them. So first up, we're going to multiply this decimal which we have so that the recurring section, the 4 and the 2, is immediately after the decimal point. Now in this case, I'm going to have to times it by 10. So if I call that x, if I multiply it by 10, then I'm going to have 3.4242, etc. Okay, so that's step 1. Then step 2, if we have a look back at the bottom, says to multiply again so the next recurring section is immediately after the decimal point. So if we break this down into recurring sections, there's 1, there's 2, there's the end of that. So we're going to have to multiply it by 100 more to move it up so that this 4 ends up just after the decimal point. So if we started with 10, we're going to be timesing by 100 now, so that's 1000x, 10 times 100, and that's going to be 342.4242, again dot 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 dot. Okay, so to get from this line to this line, we're going to times by 100. As a quick check, you're just thinking about how many positions have been filled up by the digits. So if there's one digit in the recurring section, you times by 10 at this stage, but as there's 2 digits recurring, we'll times by 100, 3 digits would times by 1000. Step 3 then, subtract equation 1 from equation 2 and then solve it. So 1000x minus 10x gives us 990x, and the beauty of doing this way is that all of this recurring section on the right, if we do that, subtract that, they're just going to cancel each other out. So all we've got to do is 342 minus 3, which is 339. From that point, we're just going to do some division. So x is going to be equal to 339 over 990 if we divide both sides by 990. Obviously, we can then simplify that. That will give us 113 over 330. Let's try another one. So first of all, we have got to multiply so the recurring section is immediately after the decimal point. So here's what I'm going to call x. In this case, it is already starting straight after the decimal point. So all I need to do is just write that down. X equals 0.5353, etc. Step 2, multiply our x thing so that the recurring section is after the decimal point again. We've got the same situation this time. We've got 2 digits in our recurring section, so we're going to need to times by 100. So we started with x times by 100 gives us 100x, and now that's going to be 53.5353, etc. Step 3, we're going to subtract all of this from that, like we do with simultaneous equations. So 100x minus x gives me 99x. Then we're going to look at the right hand side here. All after the decimal point is going to cancel out, so we're just doing 53 minus 0, which is 53, and then we can divide by 99 to give us 53 over 99. No simplification in this case. Last example, so we've got 0.12543 with the recurring section being the 5, the 4 and the 3, as that's where the dots are. So we're multiplying so that recurring section starts straight after the decimal point. So we want to move the decimal point from here to just before the 5. And to do that we'll have to times by 100. So 100x equals 12.543543, and that's going to keep repeating. Now to get that back in front again, so there's our recurring section, to get this recurring bit to get up, we're going to have to times that by 1,000. So we've got 100 to start with, we're going to times that by 1,000, so now I've got 100,000x, and that's going to be equal to 12543, so 12,543 with the recurring section after it. Step 3, again, is our subtraction, so 100,000x minus 100 is going to be 99,900x. On the right hand side, everything after the decimal point cancels because it's all the same using the method that we've got. So it's going to be 12531, 12,531. And so x is equal to 12,531 divided by 99,900. Now you're unlikely to get one that is that complicated in your exam, but at least this way you know how to do it. You can also divide that one by 3 to simplify it. So bottom nice and easy, we're going to have 33300, and then 3's into the top, go 4 times into 12, once into 5, 7 times into 23, and 7 times into 21. If you want to try a couple by yourself, try this. So we've got 0.143 with those 2 dots, and I'll give the answers straight out so you can check if you're getting them correct. And then as a second one, try 0.78, the answer for which is 78 out of 99. And the last one can be 0.026.7, and the answer for that is going to be 53 over 1,980 in its most simplified form.